The scene opens with botanical drawings and images of ancient orchards. A forbidden graft is introduced, a fruit created by human intervention. This creation blurs the lines between science and traditional practices. The mysterious tone hints at the fruit's unique nature and disappearance. The graft evoked controversies and fears within society. Some viewed the graft as unnatural and morally objectionable. Others considered the graft dangerous, raising safety concerns. Ethical considerations and societal anxieties contributed to its decline. The scene highlights the fruit's disappearance from cultivation. It underscores the quiet loss of a specific graft variety. The scene transitions to explore reasons for its abandonment. Factors include scientific, traditional, and societal influences. Grafting is a horticultural technique used for over 3,000 years. It is distinct from genetic engineering. Grafting combines two plants to harness their best traits. A rootstock provides a strong root system. A scion provides desirable fruit characteristics. Grafting enhances fruit characteristics in various plants. Grafting can result in sweeter apples through varietal selection. It can also produce juicier oranges by combining desirable traits. Grafting is used to cultivate disease-resistant grapes. Grafting merges plant varieties to improve fruit quality. Grafting is the primary method for fruit tree production in the United States. This widespread practice highlights grafting's effectiveness in agriculture. Grafting helps maintain fruit tree quality, ensuring desirable traits. It also enhances fruit tree yield, increasing overall production. Grafting experiments date back centuries in Europe and Asia. These experiments involved apple, pear, and quince trees. These fruits are related but possess genetic differences. Genetic differences pose challenges in grafting these trees. Historians and horticulturists study these early grafting attempts. These studies provide insight into grafting compatibility. The chimera fruit shows combined traits from different fruits. It features apple-like sweetness and pear-like texture. The fruit also possesses quince-level durability for storage. Fruit traits are inconsistent, varying across seasons. Cultivating chimera fruit presented significant challenges due to its unpredictable nature. The taste varied widely, ranging from exceptionally delicious to unpleasantly bitter. Fruit shape was often irregular, affecting marketability and consumer appeal. Improper growing conditions sometimes led to mild toxicity, making it an unreliable crop. In pre-modern societies, food production was deeply connected to belief systems. Crop failures were often attributed to supernatural or unnatural causes. Unusual fruit appearances were also seen as signs of spiritual influence. Illnesses affecting crops or people were linked to the spiritual realm. This reflects a worldview where nature and spirituality were intertwined. Grafted fruit was sometimes negatively described as confused by nature. Some considered grafting an orchard sin or a fruit that forgot what it was. Farmers feared grafting upset land balance, angering spiritual forces. Concerns included soil depletion and environmental spiritual repercussions. Early Christian Europe viewed excessive nature manipulation as playing God. This raised religious concerns about human intervention in nature. Ethical boundaries of altering the natural world were questioned. These fears led to the quiet removal of grafted plants. Knowledge related to grafting practices was suppressed. These factors contributed to the decline of grafting practices. Grafting can sometimes lead to unstable vascular connections in plants. This instability disrupts the flow of nutrients within the plant. Some parts of the fruit may receive too many nutrients, while other parts of the fruit may suffer from a nutrient deficit. This imbalance affects the overall quality and consistency of the fruit. Grafting can affect sugar distribution in fruit. This may cause uneven sweetness within the fruit. Some parts become overly sweet. Other parts may remain tart. Chemical compounds can fluctuate unpredictably. High tannin levels may make fruit harsh or unsafe. Historically, grafting posed unacceptable risks due to the lack of refrigeration. Absence of modern testing further amplified the uncertainties in grafting. Established food safety standards were non-existent, increasing risks. Farmers valued crop reliability over the potential benefits of grafting. Safer, more predictable agricultural methods were favored over grafting. Modern horticulture allows the recreation of graft chimeras in controlled environments. Graft chimeras involve combining tissues from different plant species through grafting. This technique leads to innovative hybrids, such as apple-pear trees. Another example is the fruit salad tree. bearing multiple fruit types. These experiments highlight the potential for species combination via grafting. Modern understanding mitigates the risks of graft chimeras. Unlike in the past, knowledge of plant hormones aids in managing graft chimeras. Understanding sap flow is crucial for successful graft management. Cellular compatibility insights allow for controlled grafting outcomes. This knowledge ensures hybrid plant survival and stability post-grafting. Creating graft chimeras was once limited by understanding, not impossibility. Modern techniques now make the creation of complex plant hybrids more manageable. This showcases advancements in botanical science. Horticultural practices have also greatly improved. Grafting allows combining traits of different plants. Creating unique plant varieties is now more achievable. The discussion explores whether reviving lost agricultural experiments can solve global issues. The central question is if ancient agricultural knowledge can address modern challenges. These challenges include climate change and potential food shortages. Reviving lost techniques may also combat current crop diseases. The focus is on the potential of historical farming methods for present-day solutions. Simulations display ancient crops, including a forbidden fruit variant. These crops exhibit notable drought resistance, crucial for arid regions. They also demonstrate exceptional longevity, extending harvest periods. These characteristics make them valuable resources for modern agriculture. Ancient crops can enhance resilience and sustainability in farming practices. The disappearance of crops doesn't always mean they were unsuccessful. It may reflect past limitations in understanding or utilizing their potential. Modern research can unlock the hidden benefits of these crops. Revisiting abandoned agricultural experiments may yield valuable insights. Advanced analysis could reveal new applications for these failed crops. The act of biting into an apple connects us to nature's simple pleasures. Each apple carries a history from its cultivation to its consumption. The apple's texture and freshness highlight its natural origins. Even a common fruit embodies a rich narrative of growth and tradition. The market displays a diverse array of fresh fruits and vegetables. Each item is visually highlighted to showcase its unique characteristics. The variety emphasizes the abundance and appeal of natural produce. Each fruit and vegetable has a distinct origin and story to tell. The host introduces a variety of fruits and vegetables to the audience. These foods are presented as holding interesting stories. The host smiles, engaging directly with the camera. The gesture invites viewers to explore these stories further. The setting is an indoor studio, creating a controlled environment. The scene aims to pique curiosity about the narratives behind common foods.